Hey, what's up, guys? Today we're going to be doing another question, which is just a balanced binary tree. We just need to determine whether the tree is balanced or not. So, for every level, both the left side and the right side should be balanced. So, it basically is a binary tree in which left and right subtree of every node differ in height by no more than one. So, basically, there's a height difference of one, but that's acceptable since we are given that it's okay for that to do. So how can we do this question? So the basic idea would be here to just calculate the depth at every node. So say I start with 3. I say I want to go left, and then I want to go left again. Now here it is null. So I say I do not return any depth back to 9. So 9 still has a depth um, of say 0 for the left hand side, so its left side just becomes 0. And then right side also doesn't have anything, so right side is also 0. Now 3 is gonna say, okay, I am gonna say I want to return whatever depth of your maximum child is and plus 1 because of u itself. So it's just gonna say 1 plus max of left or right. Since left child and right child both return a 0, that means this will also give a 0. So 3 has L1. Now, once we have this depth for here, we just need a depth for here as well. So now right side got executed. Now here the left side got executed again. This would say, okay, I am 0, right is also 0. That means this thing has a depth of L as 1. Similarly for this will also return it the same thing. So right is also 1. And then we are going to just say 1 plus max of these two things, which is just going to be 1 plus 1, 2. So now we said that the left and right subtree of every node cannot differ in height by no more than 1. So if I just say that absolute value L minus R, if it's greater than 0, then we found an imbalance in the tree, right? That's how we found an imbalance. And then that's basically it. We solved the question. So say we have this method of calculating the depth, then our base condition is very simple. If it's a null, then return 0. Because if it's a null, it's not contributing to the height at all. So that's 0. Now calculate depth, root dot left. So this is my root. Now the left would go here. Then it's gonna recurse again. Then my left would go again here, which is null. It will return. So my left just becomes a 0. Similarly for the right, it's gonna go null here. Right also becomes 0. And this would check the condition. Since both are 0, that means there's no imbalance really. Thus it's gonna return to 3. So 3 left is 1. Because we return 1 plus math.max left dot r. Now it's gonna go to the right by this recursion condition. Then it's gonna calculate for the left. Since this is a new whole recursion, then it's gonna go here. And then as we discussed previously, we're gonna get the answer of 2. So that is basically the code for this. Just so we have an idea of how it's working in an unbalanced tree, let's go for it. So go here, go here, go here. Return me a 0, so it gets 0, both left, right. This one becomes 1 for the left. Goes here, again becomes 1. Goes here, becomes 2. And then this one gets to the right. It says, okay, I'm gonna return it null here, so I'll just get 0. I'm going to return it 1, so r becomes 1. Then this is going to go 1 plus max of left right, which is becomes 2. This becomes 3. Okay, perfect. So L is 3 here. Here we go. Now when I finally go to the right, This right is going to call left and right, which for it, this particular stack is just going to be 0, 0. It's going to return right to be 1. Now we're going to check absolute 3 minus 1 is greater than 1 or not. Well, 2 is greater than 1. So we're going to say found is true. That means we found an imbalance. Now, since I found an imbalance, when I finally, this whole thing returns to my main method is balanced, which calls this calculate depth method, I can just say return the inverse of found. Because all I want to say is this tree balanced? No, because we found an imbalance. So that's how you do this whole question. And I hope you guys found it easy to understand. And I'll see you guys in the next video.